This is Professor Nathan Palpant. He's a world expert in venom biology. And this is one of his favourite venomous subjects, the deadly funnel web. Tucked away in a lab in the University of Queensland, he and his team spend their days sourcing venoms that contain new drugs.
The observation that venoms have remarkable drugs in them has been known for many decades. In fact, molecules including captopril, which is one of the most famous and most widely used drugs for reducing blood pressure, was derived from the venom of the pit viper.
Right now, it's the Fraser Island funnel web that's under the microscope. The venom was found to slow down brain injury from a stroke. And now there's a link to the heart as well.
We have known and been studying for decades the underlying stress responses that happen in the heart during an injury like a heart attack. But the remarkable problem is that actually no drugs have actually made it into the clinic that block these injuries from happening. So we know a lot about how they happen, but all that knowledge is actually not delivered anything clinically to impact patients.
That is, until now. Incredibly, the poisonous venom contains a molecule that slows the death of heart cells during a heart attack, buying time for the victim.
It's effectively telling the heart cells just to hang on because they're in a very serious stress space and they really want to die, but this molecule comes in and says, just hang on for a little longer. And that's really important because as patients are experiencing a heart attack, they can get to hospital and they can undergo all of the procedures that help restore the blood flow. But the heart cells really need to just hang on through that stressful period, and that's what this molecule does.
And if that isn't the most incredible thing you've ever heard, then how about this? The venom contains around 3,000 different molecules, and only one of them has the power to prevent what they call cell suicide, the potent HR1A.
We've studied this in the context of stroke, where oftentimes patients require a long time to get to hospital before they can have a diagnosis. And so that creates a long injury period where the cells are dying. And we've found that treatment with HI1A, even up to 8 hours after the onset of stroke, still reduces the injuries that happen in the context of those types of stresses. We've also found that in the context of heart attacks, we can deliver the drug just prior to effectively the surgeon getting in and restoring blood flow. So long injury periods before we deliver the drug, and it has remarkable effects in regard to the preservation of those organs and the function of those hearts.
And there's more. Extending the life of heart cells will have a huge impact on donor hearts and transplants.
And the heart is really one of the most sensitive to this transport time period. And so clinicians are really restricted to just a few hours of being able to get it from a donor to a recipient. And in Australia, that's a big problem because we have this issue of the tyranny of distance, and transporting a heart from Perth to Brisbane, for example, isn't feasible. And so our hope here is that the observation and the discovery we've made would be a significant impact to increasing that transport time so that we can really distribute the organs more effectively across the country and also improve the quality of those organs for the recipients.
Clinical trials are well underway, with the ultimate aim for first responders to administer the drug at an emergency.
The exciting aspect of this study is that we've identified a molecule from a sand island off the coast of Queensland. We here at the Institute for Molecular Bioscience have discovered its remarkable capacity to improve the value and the quality of organs that are injured in the context of stroke and heart attack, the leading causes of death in the world. And so this is an exciting opportunity, I think, for us to move this forward into an area of clinical need that could impact millions of people every year.
So, if you're not a fan of spiders, here's the last word from Nathan.
A bit more appreciation for those little critters that crawl around with a bit of a scare, but they might actually help you in the long run.